Okay, on this section, we're going to be talking about some basics of logic. We're going to be doing some truth tables eventually. We're going to be talking about some things that's used a lot in the computer science field, actually. And we're going to start off with some basic definitions. Let's talk about what we mean by a statement. A statement, as with the real world, a statement is a sentence that can either be true or false. This is called the truth value of the statement, whether it is true or false. We can represent this statement with letters such as P or Q. So an example of this, statement P here. Supplementary angles have a sum of 180. We know by definition that is true, so the truth value of that statement is true. Just like taking a true-false test, there is absolutely no difference. A negation. A negation of a statement has the opposite truth value. Opposite. There we go. Shown with the little squiggly symbol is what we use. And this is read as not. Like if you've got the not symbol in front of a P, as you do here, this is read as not P. So if we go back and talk about our statement up here, supplementary angles have a sum of 180. The negation of that, you can think of it as being like an opposite of that, would be supplementary angles do not have a sum of 180. And the truth value of that would be false, because we know that they do have a sum of 180. So again, a statement and its negation, or a statement and its not, will always have opposite truth values. Next up, compound statements. And a compound statement is just like a compound sentence in English. A compound statement would be two or more statements joined with our conjunctions here, which we're going to be talking about in just a second, joined with and or. Okay, joined by one or the other. Conjunctions and disjunctions. Let's talk about the ands and ors here. Conjunctions are statements joined by the word and. The symbol for a conjunction is like a little pyramid. This written as this, and this is read as P and Q. Now let's talk about what it means to be a conjunction. In order for P and Q to be true, it is true when both, that is a very important word here, it is true when both statements are true. Very, very easy to find some real life examples of this. I always like to use going to the fair and riding a ride. In order to ride a ride, let's say that you must be 5 years old. Whoops. And let's say 4 feet tall. Okay, now this word and is very important here, because in order to ride this ride, you must be 5 years old and 4 feet tall. This is again, this is a conjunction. It's an and statement. So in order to ride this ride, 5 years old and 4 feet tall. What if you're 5 years old and 3'11"? You can't ride it. Why? Because since it's a conjunction, since it's an and statement, both must be true. What if you're 6 feet tall, but you're only 3 years old? That'd be odd, but you still can't ride. In order for this conjunction to be true, both statements must be true. Now let's talk about a disjunction, though. Disjunctions are statements joined by the word or, and it's got the upside down V-shaped symbol, P or Q. Okay, and you can use the exact same example from above. Except for what if this were an or instead of an and? 5 years old or 4 foot tall. These statements are true when at least one statement is true. So they don't have to both be true. In order for this to be true, in order for it to be possible to ride this ride, you must be 5 years old or 4 foot tall. If this is true, then you get to ride the ride. Or if this is true, you get to ride the ride. If they're both true, you still get to ride the ride. So if it's an or statement, in order to get a true, or in this case, in order to the true would be you can ride, at least one must be true. Now let's go through these and let's look at what some of these truth values, these truth statements, and see if we can figure out what their truth values are. Now, the first one, this is read as P and Q. And what they've done up here is they've tell us what P, Q, and R stand for. So P and Q, P is there are 7 days in a week. I'm just going to put 7 days in a week. And Q, March has 30 days. So look at this complete statement now. There are 7 days in a week and March has 30 days. In order to have this to be a true statement, since it's an and statement, both of these must be true. And we know for a fact there are 7 days in a week. And does March have 30 days? And when they say 30 days, we mean exactly 30 days, and that would actually be false because March has 31 days in it. So therefore, in order for this to be true, this and this both have to be true. So since they're not both true, this would be a false statement. And the next one, Q and R. Here's Q, here's R. So Q, March has 30 days. The symbol, again, is an and symbol. And R is Halloween is on October 31st. So now let's talk about the truth statement of this. March has 30 days and Halloween is on October 31st. Now we know this is true, but however, from the previous example, this was false because we know it has 31 days. So in order, again, since this is an and statement, in order for the whole thing to be true, both have to be true. The word both is associated with and, so this would again be a false statement. Number 3, P and R. Again, P would be there are 7 days in a week, and R would be Halloween is on October 31st. Let me scroll up. So now let's talk about the truth value of this. And again, it's an and statement. There are 7 days in a week. Oh, that's true. Halloween is on October 31st. That's true. Since they are both true, the truth value here would be true. The whole statement is true since they're both true. The next one says not P and Q. So not P, let's start there. P says there are 7 days in a week. So the little squiggly line means not, so that means there is not 7 days in a week. Again, this symbol is an and symbol, and I'm actually going to put it in capital letters here just to remind you that these both have to be true. And then you have Q, and Q was March has 30 days. So let's talk about the truth value of this whole thing. There is not 7 days in a week. That is false. March has 30 days. That is false. So in order for this, since it's an and, in order for this to be true, then they both had to be true. Well, they're both false, actually. So the truth value here is definitely false. The next one, P or R. Now we're starting to look at some ors. P was there are 7 days in a week. Let's go ahead and write that. And again, you have your or symbol there. So this would be an or statement. And then the R is, let's scroll back up and look. Halloween is on October 31st. So for this sentence to be true, since it's an or, if at least one of these are true, then the whole thing is true. Okay, because it either or. Okay, either or. So there are 7 days in a week. That's true. So already the whole thing is true. Or Halloween is on October 31st. That's also true. So therefore, since it's true or true, and only one of them had to be true, the whole thing would be true. The next one says not Q. Okay, let's look at not Q. Q is March has 31 or has 30 days. So not Q would be that March does not have 30 days. Again, we are dealing with an or statement here, so I'm going to put that in the middle. Or R, let's scroll back up and look at R. R is Halloween is on October 31st. So let's write that down. So again, since it's an or statement, either or, at least one, not both, but at least one has to be true. March does not have 30 days. That's true. It has 31 days. Halloween is on October 31st. That is also true. So since, again, only one of them had to be true, since they're both end up being true, this would have a truth value of true. Not P, and P was there's 7 days in a week was P. So not P would be there is not 7 days in a week. Again, we have an or statement, so let's put our or here. And then we have not R, and R we can get from the last one. Halloween is on October 31st, so therefore not R would be Halloween is not on October 31st. So let's talk about these truth values. There is not 7 days in a week. Well, that's false because there is 7 days in a week. Halloween is not on October 31st, and well, that's false because Halloween is on October 31st. So in order for or, okay, in order for this sentence or this statement to be true, one or the other has to be true. They're not. Both of them are false, so this entire thing is false. And something to think about. This scenario is the only way for a compound statement to be false. If it's an or, is if they're both false. That's the only way. It's kind of like with an and statement. The only way for an and statement to be true is if they're both true. Okay, so that kind of works together. And then the last one, it says, and let me switch back to red here, not P, we did that on the last one. There is not 7 days in a week. And again, this is an or statement, so let's put or. The second part, not Q, well, let's go back up. Here's not Q. Q was March has 30 days. So not Q would be that March does not have 30 days. So therefore, in order for this statement to be, again, it's an or. So in order for this statement to be true, one of these have to be true. There is not 7 days in a week. And we already know that's false because there is 7 days in a week. March does not have 30 days. That's true. March has 31 days. So therefore, false or true. Since at least one of these are true, that means the whole statement would be true. So the next part says write some of your own, and we're not going to do this, but I am going to remind you if you have an or statement like this, the upside down and statement, or the V right here means or. In order for this to be true, one or the other must be true. At least one has to be true. The squiggly in front of a statement, again, means not. It's the negation of the statement. And then we skip down to an and statement, discussing and statements. In order for this to be true, both of these statements must be true. So both of these would have to be true in order for the whole thing to be true. Other than that, if any part of it's false, then the whole thing's false. So that's the difference between ands, ors, and how to deal with negations.